Good evening.
Okay. Yeah, so let's start. Okay. I will start recording. Yes, today we will be discussing the next foundation before starting SQL. What is the nature of uh, learning? If you learn SQL, what is the nature of work we have to do when we are doing? What is the importance of database design and how do we design? So we'll discuss about that, and slowly we will try to understand importance of SQL in this session actually. Let me start. Okay. Let me go here. Yeah. I think screen is. All of you are able to see my screen?
No, sir.
Yeah,
Now?
yes,
Yes.
sir.
Yes, yes.
Yes. Okay. Let us start. Okay. No issues. So, so today we are talking about the some of the. This is the most important steps, I can say that. Okay. Uh, if people learn SQL, PLSQL, it may be MySQL, Oracle, but finally at the end, I think we have to understand the importance of design. So what is the objective of like if I have a requirement and how to make sure that database should be designed, what are the approaches we follow? So today we are talking about like a relational way of or traditional way of database design. And when we are doing the database design, what are the observations we will make it? For example, when we want to develop a application like Amazon or e-commerce kind of applications, uh, probably the way we think, okay, and also the approach what we may make is something different currently, like for example, after the revolution of object-oriented principle. But traditionally, almost 70 to 80% members will follow this kind of approach. So that is what currently I would like to showcase here and try to make you to understand why so much, because finally at the end, information should be stored in the backend, right? Earlier days, we used to have the file system. Now we are talking about the database design. So that's the reason we have to understand what it is actually. In the last session, quickly, if I summarize, we understood what is data. Then we understood data is information fact. Then database, logically, if you group such information, we call it as a database. And next, we understood that, okay, when you talk about relational database model, RDBMS comes into your picture, where is a relational database model we are talking about, where if you want to work in the project, what kind of methodology and approach we follow, we call it as RDBMS. Many softwares are available, MySQL, PostgreSQL, Oracle, all these technologies are there, okay, to use as a database or RDBMS package. And finally, we also discussed about database system, where if you want to work on voluminous data, big data, we call it as a database system. Now the question is here, okay, if I want to design such database, okay, traditionally, what approach we follow, and today we are going to discuss. Then it will be having you will be having the clarity on that. Okay, why are we learning all these concepts? So that is more important. First, we understand the purpose of any design. And learning the language is not a big deal. So let us understand that. Then definitely we can we can able to appreciate all these things. The key aspects of database design is, okay, one is like a ER diagram. What is ER diagram? It is nothing but the how we visualize the requirement to store the data. So that is called the entity relationship modeling, ER modeling we talk about. Then once you have a requirement and you come up with ER model, then assume that you have created a scripts also. But finally, you have to understand whatever the designed database is correct or not. So that is called normalization, we call it as. When you are doing that, okay, what kind of conditions I have to put, that is called data types and constraints we are talking about. Then table design, when you are designing the table, how well you are going to structureize the data. So that is the part of in this one. And also sometimes to improve the performance, okay, some shortcuts, some improvisations we do it, that is called refinement in normalization. And also sometimes if I want to focus on certain part of the data where more queries will be given on that, then searching is more. Then we have to understand there is a concept of query optimization. And most of the applications, you could notice that, okay, there are different roles will be there, different roles in the sense there may be HR, there may be admin, there may be a student, there may be a faculty. That is nothing but authentication for those users, and also permission, what data should be shown or retrieved, what data should be hidden. So that is also most important. And security wise, what kind of information should be given, and which are the sometimes privacy data during testing. Okay, it should be data should be scrambled so that people should not able to see the data, but the testing should be done properly. So that is what security and all those things. Data integrity and validations. Okay, when you are connecting more than one data, one table, one database, okay, definitely the duplication should be avoided and correct information should be displayed. So scalability and performance, and also because once we develop the application array, then we have to manage that. Okay, then documentation to understand further is also important. So these are all the some key aspects. Let me start with, okay, a ER diagram. Why this is required actually? You don't require to, because we are not going to write any exam or preparation for the college, but we should understand traditionally how we started database design. As a data analyst today, we are talking about, we are going to against to the sometimes database normalization. That is called denormalization. That is also we are going to discuss. Okay. But my objective is here, the what I learned from past 2 decades. Okay. I wanted to bring back to the people. It is just learning SQL. It is just learning SQL is not, doesn't make any sense. It is just a syntactical representation. But that is required. But along with that, so what approach people are taking to design the database is also most important. For example, if someone studied master's or a degree, you should have noticed the title of the textbook as DBMS, Database Management System. And also sometimes the students have a complaint saying that, okay, like we don't have the advanced courses like SQL, PLSQL and all those things. See, foundation is different and whereas okay, designing the the through program is different. The skill is different, foundation is different. Here we are combining both. In next 2 weeks, you are going to learn both actually, and that will give the added advantage when you go for in a real-time work. So my objective, my goal is always to give more and more information about the real-time work culture. So that is why you people are here, just to understand that. When you talk about ER diagram, what is this ER diagram? I'm not getting into the so much definitions or something like that. Usually, there are special symbols we'll use. This is nothing but visually you are going to represent the information. Like for example, university automation, you want to do that. What information should be represented in what way? So that is what we are talking about, the visualization. That visualization diagram we are talking about is entity, representations, attributes, relationship, all these things. Since most of the people also here are non-IT people, but this foundation was missing when they are learning SQL. Please understand, when anyone gives a requirement to you, so usually requirement will be the textual information or a documentation. But if you want to convert to SQL script, before that, you have to do the designing part. That is called database design we are talking about. In today's session, it is more important in that context. For example, if I ask you to design one real-time project like similar to Amazon or e-commerce application, or something like a university automation software, if you want to develop, the first objective is to visualize the what are the nouns are there, what are the objects are there within the system, and based on that we have to create those things. Okay, and then it will be very clear that writing in the SQL script. So that is the first step we have to do. That is called entity relationship model. So when we go, for example, you'll be able to understand that, quickly understand this is a representation of object. It like if there may be a student in the requirement, teacher may be in the requirement, course may be requirement. Typically, they are the nouns actually. So typically, they are the nouns. Entities can be students, teachers, courses, fees. Okay. But always please understand, I have given here story intentionally, students we make it, but student is sufficient. Adding yes doesn't change the meaning of student. Our teachers, teachers is also same. This is also common. Teacher is also a common one. When you see that, you do not, when you creating a table, okay, in the SQL script, you do not require to add yes. Just course, teacher, student is sufficient. Then that is sufficient. Students is also same. Teachers also same. Course also. It is general name, right? Fees is also known. Instead of that, fee. So fee is nothing but it can be common noun, something like that. Representation of this, what we are talking about here, a relationship is nothing but through the ellipse kind of structure we are going to use. And sorry, this is and attributes, representations, attributes will be taken in this, like employee number, role number, these attributes we are talking. Relationship is in diamond shape. And weak entities is nothing but if you have a dependencies on certain thing, then this is a weak entity. So let us see here. there is a one scenario I have taken. Okay, student and course enrollment. Okay, for particular college or particular university, you assume that there is a student. It is a strong entity because it is independent. When you say strong entity, student itself is a independent object. Course, that is a also a the strong entity, but enrollment depends on student and course. So that's why it is a weak compared to the strong the student and course. So if student is not there, there is no concept of enrollment. If there is no course, there is no concept of enrollment. Then such entities we call it as a weak entities. Now, if you look at the student, as you are if you like a as an entity, when you look at this, okay, you have student ID, name, date of birth. So all three informations you can visualize. And also when you talk about course ID, course name, instructor name or faculty name, you can do that. When you combine this, okay, enrollment ID and enrollment date. So these are called attributes. Okay, it is a part of student columns. Like when we have a student, these are the column names we will be having. That we call it as in general name, we call it as an attribute. But like how student have the relationship with the course, student enrolls for the course, many to many relationship. That means many students enrolled for many courses, and many courses will be enrolled by many students. Similarly, the enrollment depends on the student and course. Just I'm visualizing. For example, you want to automate a software for university or a college. Assume that these are the part of the requirement. They are asking you to automate. First, you are going to identify these things like a student, course, enrollment, and also what are the informations are available. So similarly, if you have more than one attribute, then we call it as a multi-valued attribute. At this moment, don't worry too much. Just I'm giving, there is a terms, how do we design the database? We are not creating blindly, but if you follow traditionally, then definitely you have to understand all these things. Similarly, let me go get into this college management system with real-time example. Here entities are there, attributes are there. Student, if a college management software requirement, if you look into it, there will be a student, there will be a course, there will be a department, there will be a faculty, there will be a enrollment. When you look at the student, what are the attributes we have? Student ID, name, department number, email, phone, and address. Unique ID may be a student ID. Don't worry what is primary key. Definitely, I am going to explain that. Similarly, course, this is course ID, course name, credit. Department, student enrolled for the course in particular department, maybe physics department, chemistry department, mathematics department, computer science department. So department ID, department name, and maybe HOD or a location, we can show that. Similarly, faculty. Faculty is name, designation, and belongs to a particular department. The computer science teacher will belong to a computer science department. Similarly, chemistry faculty will be depend on the that is called what we call it as a chemistry department. Similarly, enrollment, when you talk about the student enroll for the course, okay, then student enrollment ID, it is referring to the student, also course, and also which date. So this is what usually we design database based on the requirement. Finally, we come up with this type of the structure when we are doing. Okay. So usually, how do we convert these things in the database? This is what we call it as a the entity relationship diagram. If I execute in the workbench, so you'll be able to see this type of design actually. Okay, if you do reverse engineering also, you can create all these things. One to many relationship, one to many. So like this, how many object of this associated with the another object? So there will be a student table. These are the columns. Enrollment, these are the columns. Department, these are the columns. This course, these are the columns. And faculty, these are the columns. So based on this derivation, what you will do in SQL? Just you will go and write the script. That's it. So that means once you learn a SQL script, you will go to create the student. You are going to with these columns, and with some constraints like here primary key is student ID. Similar to enrollment, we are going to enrollment ID. Like this, we are going to create the tables, structures, conditions. But first is our objective is to derive this. It means that if you know SQL, it doesn't mean that you are a good database designer. If you are a good database designer by learning the script, you can be a master in end-to-end development. So that this is more important for us. Before getting into the SQL, just at least you should have a high-level overview on these things. Okay, we have to understand there should be a requirement. From the requirement, we create ER diagrams. Okay, ER diagram using that. So ER diagram will be like this. So this type of picture will be there. For your reference, I have added here one. I have taken one reference from the university management system. Wherever I have referred, there is a link also I have attached. So user has roles. Okay, user has login. Login maybe login role ID, login role ID, login username, login user password. So these are the called as attributes or column names. Similarly, user ID, name, mobile number, email, and address. Actually, the user underscore name, we should not give like this as per the standards. Unfortunately, the picture what I have taken is like that. So the user is a table. Okay. In that, these are the columns: ID, name, mobile, email, address should be given, and you do not require to add one more object like user, because you are inside this actually. Okay. For example, if you are like a Ramesh dot first name, something like that. So you should not do like that. Okay. Rather, you create a user, correct. After that, you have to create ID, name, mobile, email, address. Similarly, roles, ID, name, description, role dot ID, role dot name, roles dot description, permission. So like this, we can have a manage course. The student enrolled for a course, and course has a like a colleagues, okay, a teacher or something like that. Registration, something is there. Okay, this structure, just don't focus on logic. The focus on my words. Okay, here, this is an entity, user. The diamond shape is a relationship, and these are called attributes. Okay, and these are the this is how association. This is how association. User, manage, course. Course has some it may be a course type. Okay, student. For just information, I have given this actually. At this from this diagram takeaways, if any requirements are there, you have to convert in this type of structure, and next you have to convert into a this type of structure. Once you design, come up with this from the diagram, then you will go and design this. Then you will be having the clarity. So this is how we should design the requirements. Now, when you are doing that, so if you look at here, this is a primary key it is showing. Something there is a foreign key. So we should have an idea about what are those keys also. So quickly you have to understand what are those keys and how to come up with those keys. Okay, what are the different types of keys are there? So the keys are there. So here we have a primary key. So there may be a foreign key, department ID in course. This may be a foreign key. So in department, this is a primary key. Likewise, faculty ID in faculty object, department ID is a foreign key. What these keys are? Actually, these keys are called as a constraints. What is? This is a constraints. What are those constraints? Are conditions. Like conditions or constraints means that on a particular table, if I want to apply some insertion, deletion, update, or something like that, join, I have to come up with certain rules. Those rules are standardly called as in database word constraints, or rules or conditions also, I can say that. But technically in SQL or in database design, we call it as a constraint. So when you are creating a table, we are always come up with a constraint. What are the different types of constraints we have? First one is primary key. Okay, first one is primary key. Please remember, if you really want to design the database, you should have an idea about what is primary key. So for remembering purpose, I will tell you primary key is nothing but it should be unique, but not empty, not null. That is called primary key. That means if there is a student database having student ID, student name, age, some other columns, okay, which is the unique here? So unique is student ID. Name can be repeated, age can be repeated, but unique is student ID. When the student ID is unique, roll number is unique, okay, and it should not be empty at any stage, okay, because if this is empty, there is no meaning at all for this record. In such cases, such columns, we call it as a primary key. So without any table, if you design, so without primary key, you should not design any database. So that is the meaning. So primary key means it is a unique plus not null. Please remember this. What is primary key? It is unique. As a definition, I may say that uniquely identifies a record in a table. Uniquely identifies a record in a table, or it may be a it may be a column name within a table in such a way that it should be unique. So when you are saving the information into the database, we call it as a primary key. This is actually. Similarly, if you, that means in this table, if you go to that, in student ID is unique. In enrollment ID is unique. In department ID is unique. In course ID is unique. In faculty ID is unique. So these are all the candidate of primary key. So when you are designing student ID is primary key. Course ID is primary key. Department ID is a primary key. Faculty ID is a primary key, and enrollment ID is a primary key. I'm telling you repeatedly because I believe that most of the people are from non-IT people. Another important condition we have is foreign key. What is foreign key? Foreign key, only one thing you should remember, it should be a column or a primary key of some other table we are referring here. So that means student ID is a primary key of the student table, and this student has enrolled to a particular course, 1001, enrolled to a CSE. The course ID, course name is a course table. In the course table, which student has enrolled? I have added the student ID. Then what is this foreign key it is talking about? Foreign key of student says that student ID, that means there should be one table which is having the primary key as student ID, and we are reusing it. This is called foreign key. I am referring from main table to another table, which is a primary key. So it should be a primary key. Okay, such references we call it as a foreign key. The such references we call it as a foreign key. For example, here, if you have a student ID, it is a primary key. Okay, for example, if you look at that. So if you have a department table, department ID, department name, and HOD for a department is there. Now, if you want to refer faculty works for particular department. So if I want to say, I have given the all faculty information. Faculty ID is a primary key, faculty name, faculty designation. But faculty, how he works with department, then I have to tell which department. If you want to tell which department, this should be a primary key in that table. Department ID is a primary key, so I have added here. So then this is a primary key of another table. Referring here, this is called as a foreign key. So that means unique and not null, like a faculty ID, it should not be null at any time. That is a primary key, and that is a unique. And department ID is a primary key of another table we are referring here. Like this, we are establishing the association of one table to another table through the concept of foreign key, That means we have understood what is primary key and what is foreign key. There are other constraints also there. Through syntactically, you can write in MySQL, SQL Server, SQL. For example, like email ID. So this is not a primary key I have taken. Probably I would have taken, but I have not taken. So in that situation, customer ID may be a primary key. Name is not unique, so it cannot be a primary key. But email ID can be a primary key. Email ID can be a primary key if you are not good, because anyhow it is unique. But if I want to express that, okay, some columns are always unique, then we can call it as a such constraints, we call it as a unique constraints. In the interviews, most probably they will be asking what are the different types of constraints are there, or conditions are there. However you are good, if your foundation is not up to the mark, then probably people will always not select you. So because of that reason only, I always tell you, please focus on the foundation. Foundation is much more important for you people. It just takes just extra 30 minutes, 40 minutes. Don't neglect this, because finally when you become a team lead or an architect or given an opportunity to design the database, you should have to have primary skill. Just writing the SQL script, it was given by someone else. That doesn't make any sense. You have to understand, as a developer, as an analyst, you should always have a clarity on that. Why this field, what kind of column value it has, that only you can able to appreciate this. Here, customer ID is primary key. Here, email ID is unique. So if you want to say that this column always you should have the unique, then we can, that constraint we call it as a unique constraint. Now I am not debating how to create a unique constraint. When we come to a data definition language, creating through the SQL, we'll discuss. At this moment, I'm not worried about this. Similarly, another key we are talking about is a candidate key. Okay. For example, if you look at this table, here employee ID is a primary key. Name is not unique, leave it. But Aadhaar number is unique. In India, Aadhaar number is unique because for example, if you go to US, SSN number or a social security number or some number may be unique. Similarly, in India, everyone 1.4 billion population. If you look at that, okay, the crores population, so 140 crores population. If you look into it, so Aadhaar number, everyone has it. Even the child when born, we are getting the Aadhaar number for that. It is mandatory, right? So that is unique also. So then, when like this is also can be made it as a primary key. This also can be made it as a primary key. But both are candidate key. Whichever is chosen is a primary key, and the key which is not chosen other than primary key can be a candidate key. That means most probably we should have taken this, but we have not taken. So that is called candidate key. That means this is eligible. All eligibility it is there to become a primary key. For example, sometimes if you go for a job, you have all eligibilities, but unfortunately, only one post will be there and only one person will be get selected. So the person who got selected can be a primary key. The person who are not selected may be a candidate key. So that means in a database also, when we are designing, we will be having a primary key. Also, we will be having the candidate key. That means there are many columns which are eligible to become a primary key. Unfortunately, we have not chosen. That is called candidate key. This is most important for the database design purpose also, for interview purpose also. Similarly, if you go for the other keys like a composite key. What is composite key? Composite key means, like for example, if I want to say marks, if you observe this table, there is a student column, there is a exam column, exam ID column, and marks. So always, just if I say student ID, I cannot tell the marks because this belongs to some particular test or exam or a subject. Then, if you want to tell marks, first I have to tell the roll number, and also I have to tell what is the course subject ID or exam ID. I have to tell that. Electronics 001 for paper first, okay, and student ID. Together it can become a primary key, it becomes unique. But in this situation, then combination of student ID and exam ID can be make it as a primary key. So that is how, based on the situation also, more than one, 2 or more columns, if you combine, then such keys are called as a composite key. Many times, for example, you have taken a loan, there will be a loan entity. Similarly, there is a payment, that is a payment, there is another entity. So loan ID, payment ID. If I know both, then I can say what is the EMI cost. So that is nothing but loan payment. That means loan ID and payment ID together, it becomes the primary key. Such keys we call it as a composite key because It is made up of, based on the situation, 2 or more columns. So that is what we call it as a candidate key. So there is another important key, which is also most people get confused about this, super key. Okay. People are talking about the one or more attributes that can uniquely identify record, but it may contain extra attribute that unnecessary for the uniqueness. Okay. Here, if you look at here, book ID is there, author name is there, title is there. Okay. So here, book ID and author name together, I can make it as a primary key. But if you open and see that, okay, logically, book ID is sufficient to become a primary key. That means author name plus book ID can be made it as a primary key, but book ID itself is sufficient to make it as a primary key. Such keys, okay, we call it as a super key. So book ID is alone is sufficient in that situation. Some situation, then such keys we are call it as a uniquely when you combine, that can be made it as a primary key, but in that book ID is sufficient to give the record. That means it is a super. Okay, we can say that either book ID is a super key which is able to identify without combining with author name. So that is also possibility. But sometimes book ID plus author name we can get the title of the book. So that means we have to book ID sufficient, but author name sometimes we take it, then it becomes this one. But if you believe that, okay, only book ID is sufficient, even though this scenario, then book ID is the super key. So these are the normally people are talking about as a different types of keys. So usually, normally, if you go for any interviews, most of the time they will ask, how do you design the database? Okay, how do you start a database? If I give a if you go to a small startup where you are the team lead, you are the architect, what approach you follow? Okay, to design the database. Then you have to tell all the working process, right? Okay, working process in the sense like how do you collect the requirement? How do you visualize as a ER diagram? Then after that, like how do you identify the different types of constraints? Okay, and that's why most of the people are very good at SQL scripts, but unfortunately, sometimes people are having this issue. Rehana, you have question? Yeah, tell me.
For the super key, if book ID and author name are together used as super key, can there be a multiple entry for the author name? Like if there is book 003 and written by Chetananda itself,
you mean to
there
say
will be two
multiple
entries.
author names?
Pardon, sir?
Multiple author names?
Yes.
Huh?
Yes.
So see, book ID is sufficient. Sometimes what we'll do is book ID plus author name.
Okay. Now my question is that for a super key, should both columns be unique?
No, see, usually always we look for primary key is nothing but unique combination only, right?
Yes.
Okay, but here sometimes based on the scenarios, what we'll take it in the code, we combine more than one columns. Like here, what this scenario, book ID also you have taken and author name also you have taken. Okay, so the combination book ID itself is self-sufficient, but for our this thing convenience, we also taken author name as a unique. So we consider for our scenarios for that, then this could be a the super key. Book ID comma author name is called as a super key. But actually speaking, book IDs can be just alone can be a primary key. I'm talking. Yeah. Rehana, so is it your question is answered or do you have any other question?
No.
Okay. So what exactly super key is nothing but there will be a primary key. See, there may be 2 columns, 3 columns I would have taken. Okay. But without that also we would have taken 1 column. But for more convenience way, sometimes what we'll do, we will use it. Then we call it as a more than a super key, primary key. This is super key we call it as. Okay, but when you are implementing as an implementation, remember, we don't know what is super key. In SQL script, we always say only primary key, foreign key. But logically, I'm talking here today is what are the different types of keys. when you go for MySQL, Oracle, or something like that, there is no keyword called super key. Instead of that, you have to use the screen the script primary key only. Okay. So these are the different types of keys actually. That means we have understood when you are designing the database, we have a primary key, which is the unique and not null. For foreign key, primary key of another table referring current in the current table. The unique key, that is nothing but unique, like email ID. And after that, we discussed about like a candidate key. It is eligible to become a primary key, but it is not selected to become a primary key. That is all possible keys can be considered as a candidate key. More than one column, if you take such keys are called as a composite key. And super key we have selected, but in that column, there is some keys self-sufficient. So still we consider for extra care and extra, that is called as a super key. Okay. So this is about the constraint. So any questions before proceed to the next stage? That means currently we understood, if I want to design the database, we collect the requirement. Once the requirement is taken, we identify what are the entities, that is nouns in a requirement document. And then we identify what are the attributes. And then we try to identify the association, one to many, many to one, how we each other. Then we write one simple diagram, we call it as a ER diagram. And once you write that ER diagram, in that columns, and we are going to segregate what are the conditions or rules I have to put, and what are those conditions: primary key, foreign key, unique, and super key, and candidate. So I think this is clear for all of you, right?
Sir, I have one doubt.
Yeah.
So unique key and candidate key both look similar, right? So what is the difference in that?
See,
Because
candidate key and unique key both are similar. For example, I want to explicitly say that candidate key is I should have taken as a primary key, but there is when you unique, I could have taken the null also. Okay, primary key, unique also should be there. It should not be null. Please understand. Primary key means unique and not null. Whereas candidate key, it satisfies all the rules and regulations. It is if you take any table, I may be having 10 the columns which are having out of 25 columns, maybe 8 to 10 columns. All the columns have the definitions of what we call it as a primary key. Assume that. But I cannot take all the columns, right? I have to choose only one. That means candidate key is nothing but all 10 people are eligible. They are unique and not null. Anyone you can select, but you have selected key is called as a primary key. But unique is nothing but it should have it should not have the duplicate values. That is the only difference actually. Unique plus not null is if you add, that becomes the candidate key. If you select that, then it becomes a primary key. But unique key, null may be one candidate column. Got it?
yes, I got it.
Yeah, null may be one value in the uniqueness.
Okay.
Okay, but in primary key and candidate key, it is always unique and not null. And which key you have chosen is a primary key. Okay. Any other questions before continue? Okay. Okay. So I think just 10 more minutes are there. Just I will give the background. Tomorrow I will continue because this is more important. SQL learning is not at all a big problem. It is very easy only. I'm 100% guarantee that, okay, within next 2 weeks, you will be mastered in database. You will be able to write any queries. But only thing is, I need a proper foundation. That's why this what we call it as a 6 to 8 weeks. We are looking for the foundation where we are covering next 1 hour. We are covering C programming, where logic can be built. Okay, and we are talking about database in this session. Okay, and object-oriented concepts we'll be talking about. And now designing the object-oriented way is something different. Okay, all these things, most of some of the things we got in journey by experience. Okay, so all these things helps you people to become a better the best coder, I can say that. If you are best designer, if you want to be best designer, that means you have to, everything cannot be explained through the textbook. Rather than some experience and exposures also we brought in this session. That will help you actually. So please focus on that. Don't neglect this. Okay. Now let us come to a normalization. People are talking about, if you go to the any interview, they will ask, what is normalization? Okay. And what are the different types of normalization we have? Like normalization, for example, if I am a MCA graduate or a MTech graduate, okay. Like for example, one company will come and it will interview me and they will select. Okay. Now the question is here, on what basis they have selected? Based on my MTech course or MCA course or BCA course, because we are belongs to a computer science background. But the same company, they will not go to the higher BA or BCom by going to their college. The reason behind that is they are not from the computer science background. Because they have lack of some skill foundations like data structure, okay, or algorithms, okay, or C++. These type of things they were missing actually. Now, if I want to say that, okay, for these people, if I want to make it eligible, then we call it as a normalize. What is normalize in the sense that we are making eligible, okay? And if you want to make it eligible, like that means the non-IT people should do some basic foundation course, then they are eligible. So that means like all the database, when you say normalization, based on the requirement, you have designed like this. But what is the guarantee that this data, whatever the design you have done is accurate? Accurate in the sense it is useful, okay? Or it won't be having a future problems or anomalies, we call it as. So to overcome that, then we have a concept of normal. It is a process of certifying the given data in a database. That's all we call it as a definition. If I start talking about here, how well this database, whatever you have created, and you are going to organize that. That is, which is the process we call it as a normalization. Normalization is the process of organizing the data in a database. What is the primary objective? We want to minimize the data duplication, ensure data integrity and consistency. That means you are having the you have designed database like this, but someone should come and say that whatever I have designed, is it correctly I have done or not? Self-review, I have to make it. If I want to make a self-review, I should have certain rules and regulations through that I can able to verify it. That verification process, I can say that normalization. By the end of normalization process, I should say that confidently I have minimized the data duplication across the database. And there is no question of challenges of data integrity and consistency. I have followed all ACID rules, okay? And if we want to say that, so that's why we need to understand this process. Most of the interviews for freshers, almost if they are asking question, definitely first or second questions will be about database means what is normalization? How do you normalize the table? Okay, they expect which normal form your database should be. Okay, it should be minimum third normal form. So that means that kind of answer they were expecting. And if you want to understand that, okay, this session will be helpful actually. So why normalization? Reduces the redundancy. What is redundancy means? Repetition of same data in multiple places. That is the one solution we have. Another one is improves data integrity. Okay, consistent, accurate. 10 times if you do transaction, 10 times you join the table, there won't be any misplace of data. So if you follow that to ensure that we have to verify with normalization process. Prevents update anomalies, minimizes issue during data updates, deletion or insertion of the records. Multiple table if I am inserting, then prevents the update anomalies. Optimizes queries. Okay, the performance is most important. Select star from employee. If it is a 1 lakh records is okay. If it is 1 trillion records are there, how efficiently read it? How do you improve the performance? So how many columns I have to take it for the query purpose? How I should represent properly. So all these things will be better understood through the concept of normalization. So normalization is nothing but at this moment, please remember it is a process to certify a given data in a database. We are going to certify that. Okay, this is the process of normalization. If it is in first normal form, it is remove these type of problems. Second normal form, it removes the XYZ problem. Third normal form, it removes some more problems. It means that if your database is in third normal form, people will accept to design the database, whatever you have designed is correct. The majority of time, we do the review. What we review by inserting some dummy records, some modifying. We will verify the schema or structure of a database. Along with that, we are measuring what kind of anomalies it will come and it has overcome. So based on that, we can make a better decision. That means normalization is the process to certify a given data in a database. That is what we are talking here actually. So in that we have 5 normal forms we are going to discuss. One is the first normal form. In tomorrow's session, I will take with an example for each one so that you have a better understanding. Then as a data analyst nowadays, we are talking about so much about normalization. We separate the data and keep properly. But when you come suddenly as a data analyst, we are going against this. If I want to certain reports, we need to combine so many columns, okay, in one table for the performance purpose. So that is, we call it as a denormalization. So nowadays we are, even though sometimes we have to work on denormalizations also. So that is why we are going to talk about that as well. In the tomorrow session, we will talk about normalization and we will also talk about the denormalization. And also we can take one example use case for normalization process for complete design to till the scripts. And also we can take for the denormalization steps. Okay. Once that is we understood, then we'll go for the understanding on the SQL scripts. In SQL, we have 3 important concepts: data definition language, how to use it, DML, data manipulation language, and third one is data control language. If we are able to understand these things, SQL is nothing. So it is very easy subject only. Only thing is we have to just focus as a data engineer, as a data analyst, as a web developer, and this is a foundation for them. And we are going to see in next 2 to 3 weeks complete understanding about the database design. Always we are in hurry to learn advanced courses, but we forget the foundation. And because of lack of foundations, we always struggle to do a good job in the current. Always team lead or architect, whenever they review the code or database, always shouting on us. The reason behind is no one is there to teach you, rather than, okay, you have to learn by self. But you make it this opportunity so that you can understand better and you can ensure that you can design the better database design. With this note, today we can conclude. We can join tomorrow at the same time. And whoever wants to join for the foundation course for C programming, please join at 8 p.m. Thank you very much. Thanks a lot.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.